Okay, go ahead. Tell me the from.
X to the fourth power times x to the fourth,
X to the fourth.
parenthesis, x plus y equals, parenthesis equals, y squared, parenthesis, 3x minus y, parenthesis.
Like this?
Mm-hmm.
So how did you start it? Yesenia?
I multiplied it first, simplified
Yes.
it.
That's the best way to do. So it'll be x to the fifth plus x to the fourth y equal to 3xy squared minus y to the third.
So I have a question here. Anytime that we can simplify it before we start the problem, should we?
Yeah, you can do that. You know,
Okay.
The question is like, would that make it easier or not? Right? If it's not easier, then why do you want to do that?
Mm-hmm. Okay.
So right here, if you do that, then from my point of view, doesn't really make much of a difference right here. Right? You still need to use the product rule. You didn't get away with the product rule anyway.
Mm-hmm.
Get my point? So therefore, when I take derivatives on both sides, derivative with respect to x of x to the fifth plus x to the fourth y, and derivative with respect to x of 3xy squared minus y to the third. Then this will become 5x to the fourth power plus, now I'm going to use the product rule, 4x to the third y plus x to the fourth times y prime. See that?
Mm-hmm.
And then that is equal to, and now I'm going to use taking derivative of the first term using the product rule. So that will be 3 times 1 times y squared plus x times 2y y prime using the chain rule right here, minus now taking derivative of the second term, which is 3y squared times y prime. Before I move any further from here, where did you go wrong? Did you get the left hand side correctly?
I did, but I just wrote it out differently. So
How did you write?
4x 3y, I put it on like at the end of the problem. So it was like opposite. So x to the fourth times y prime plus 4x third y.
It's fine. That's fine. On the right hand side, did you get the right hand side correct?
Yes.
So
Yeah.
any other questions? Anybody? So now this will give me 5x to the fourth plus 4x to the third y plus x to the fourth y prime equal to 3y squared plus 6xy y prime minus 3y squared y prime. So this will become 5x to the fourth plus 4x to the third y, and moving this guy to the other side, minus 3y squared, and moving this guy to the right hand side, which is 6xy y prime minus 3y squared y prime minus x to the fourth y prime. So now my final answer will become factor out y prime and then divided by the rest of it, which will become 6xy minus 3y squared minus x to the fourth. I think this is the best I can do on simplifying part. Is that the book answer? I don't know if the book simplified further or not.
No, I think the book answer was 3y squared minus 4x to the
Ah.
fourth minus 4.
Say it again. 3y squared.
It was, yeah, so that's positive, and then 5x to the fourth is negative.
And then? Minus 4.
Over x.
Is it like this on the
Yeah.
top?
Yeah. Wait, 3y minus 4x to the third y. Yeah.
Okay, so then the bottom will be x to the fourth plus 3y squared minus 6xy, like that.
Yeah.
So the same thing. It's basically you factor out the, is this because like depending on which side you are isolating y prime on this step, and the negative and positive sign is different. So basically, if I factor out the numerator negative and then multiply that negative to the bottom part, it will be the same answer as what the book is saying. So,
Okay.
this step, depending on where you are isolating the y prime, that will be different, right? By a negative factor.
Mhm. Okay, and I have another question. So you know how you use y prime? Well, when I do it, I've been doing d over dx.
You should
is
be
it
saying dy over dx.
dy over dx? That's the right way to write it, right? Okay.
Yeah, it's perfectly fine. But writing down dy over dx is basically too much work. See,
Yeah.
dy dx, and then in the middle there's a bar, so you have to write 5 times, and a y prime you only need to write 2 times.
Yeah.
So it's basically the same symbolic part, right? The same meaning.